Assembly number 2 evaluated the overall performance of an exposed wood I-joist floor system, typical of a single-family residence with an unfinished, unprotected basement ceiling. The assembly is made of engineered wood I-joists, tongue and groove-oriented strand board sheathing, carpet padding, and carpeting. Temperatures are reported in degrees Fahrenheit. Temperatures were taken from thermocouples located on the finished floor surface, on the underside of the subfloor, and on exposed components of the wood I-joists. Deflection, or sagging, of the assembly is reported in inches and is based on an array of instruments placed on the unexposed side of the assembly. As the test begins, a torch is inserted in the TIC view. The display background changes from yellow to blue, and the relative temperature scale indicators change as well. This is done to emphasize the importance of understanding that these visual indicators represent relative temperature differences, not absolute temperatures. At 55 seconds, UL staff observe visible charring of the wood members. Then, the unprotected wood I-joists at the rear of the test furnace ignite. The highest recorded floor surface temperature is 72 degrees, while the highest recorded temperature on the assembly structural elements is 865 degrees. The TIC does not provide indications of these increasing temperatures below the floor assembly. The flooring materials, in this case carpeting, padding, and subfloor, are masking the camera's view of the fire below. Now there is a clear progression of flame propagation from the rear of the furnace towards the front as additional wood I-joists ignite. The change in fire behavior during this period is indicative of what would be observed as a contents fire develops into a structure and contents fire. This behavior continues and grows as the floor structure provides additional fuel load to the fire. 2 minutes into the test, smoke is visible emitting from breaches in the fire, stopping seal between the perimeter test frame and the floor. 3 small breaches are visible at the bottom of the TIC view. UL staff note the floor assembly beginning to vibrate, but the vibrations are not yet observable in the camera view. The highest recorded floor surface temperature is 75 degrees, while the highest recorded temperature on the assembly structural elements is 1341 degrees. The measured maximum deflection of the floor is approximately 1/4 of an inch. At 3 minutes, the entire floor structure is fully involved and free burning. And interaction of both the turbulent behavior of the fire and the ignition of pockets of richly proportioned combustible gases creates the fire behavior displayed from this point until the end of the test. From overhead views, minimal deflection or sag is noted near the firefighter mannequins. Recorded deflections are still less than 1 inch. Firefighters should be aware when operating on this surface in a smoke-filled environment. They would not be able to perceive this minimal sag in the floor assembly. Vibrations of the floor assembly are now easily observable and produce an overall vertical movement of 6 inches as the floor begins to sag at an increasing rate. The highest recorded floor surface temperature is 83 degrees, while the highest recorded temperature on the assembly structural elements is 1404 degrees. 4 minutes into the test, the rate of deflection progresses rapidly, with a maximum deflection of 10 3/4 inches recorded at one location, at which time 2 instruments cease to operate. The observable vibrations stop, but the floor continues to deflect at an increasing rate as the concrete weights along the perimeter begin to slope towards the middle of the floor. The highest recorded floor surface temperature is 96 degrees, while the highest recorded temperature on the assembly structural elements is 1375 degrees. Of the remaining deflection instruments, the maximum deflection of the floor is approximately 6 inches. 5 minutes into the test, cracking sounds were heard coming from the assembly. In addition, staff observed deflections of 12 to 18 inches. The fire in the furnace is still fully involved. There is dramatic deflection of the floor surface, and significant amounts of smoke can be seen breaching the assembly, but no visual flames. The highest floor surface temperature is 110 degrees, while the highest recorded temperature on the assembly structural elements is 1450 degrees. The maximum measured deflection of the floor is 14.5 inches. Just before 6 minutes, flames are visible through the assembly. The floor collapses, and the firefighters fall through the assembly. The surface reading from the tick at the time flames penetrate the assembly during the collapse is only 99 degrees. When the fire breaks through the finished floor and extinguishment begins, the floor surface appears cool in the tick view. Tick cameras will potentially provide a similar display when applied water from suppression efforts hit various surfaces. Videos and photos taken after the test indicate the excessive floor deflections at the time of collapse were partially limited as elements of the assembly came to rest on the tops of thermocouple bars located within the furnace.